Guys, for this video I go show you how you fit prove how you fit prove mean and variance for a binomial distribution. So before that, make we sharparly look wetin be binomial distribution. The binomial distribution na discrete probability mass function with many trials, unlike the binomial distribution with only one trial. That is, the binomial distribution, you know say I don explain am for the other video say binomial distribution na one trial. So if you come repeat Bernoulli for n times, you go get your wetin? Your binomial. If you do Bernoulli, if you carry out Bernoulli once na Bernoulli, twice na binomial. So if you don carry out Bernoulli more than once, na wetin? You don turn am to wetin? To binomial. So na Bernoulli na n times of a binomial distribution. Sorry, binomial na n times of a Bernoulli distribution. So automatically I don prove am say the mean for a Bernoulli distribution na P. So if binomial na n times of a Bernoulli, so it will be n times P, which is NP. So the mean for this one na wetin? Na NP. Make we sharparly look as e become NP. Make we prove am. Normal. The probability of x equals x, that is the PMF of a binomial distribution na n combination x, p raised to power x, q raised to power n minus x. Na discrete, so x equals 0, 1, 2 to n. Is 0 or is 0 elsewhere. So summation x, p raised to power x, p of x equals x. So we have summation x, n combination, these two brackets na combination I mean, n combination x, p raised to power x, q raised to power n minus x. So summation x, if you expand combination, you get n factorial over n minus x factorial as per normal now, p raised to power x, q raised to power n minus x. So if you come expand factorial, you go have n into n minus 1 factorial, because we no know wetin n be. As I don do am for here say, if you have 5 factorial, you know say you go multiply am 5 times 4 times 3 times 2 times 1 ba. But there is another way wey you fit write am, like 5 times 5, make I do am for here, 5 times 5 minus 1 times 5 minus 2 times 5 minus 3. So you go dey expand am like that till you reach 5 minus 4. Okay, 5 minus 4. Shey you grab? So you get 5 times 4, 5 minus 2, 3, 5 minus 3, 2, 5 minus 4, 1. So you go expand am to reach wetin? To reach 1. But for here you go just expand am once. We dey prove you go expand am once. So by expansion, you get n into bracket n minus 1 factorial times p raised to power x, q raised to power n minus x over n minus x factorial. We don expand this x factorial wey dey here too. So you get x into x minus 1 factorial. This one go cancel this one wey dey up. We have n summation n minus 1 factorial over n minus x factorial, x minus 1 factorial, p raised to power x, q raised to power n minus x. So if you come use multiplicative power of p abi exponent of p, that is, you come times am with something like this, p raised to power 1 times p raised to power minus 1. You know say you get p raised to power 1, p raised to power minus 1 plus 1, abi p raised to power 1 minus 1. You know you get p raised to power 0, and anything raised to power 0 na wetin? Na 1. So na wetin we do for here. N summation n minus 1 factorial over n minus x factorial, x minus 1 factorial, p raised to power x, p raised to power 1 times p raised to power minus 1, q raised to power n minus x. So we come factorize this one wey no get minus comot. We carry am out like this. So we have np summation n minus 1 factorial, n minus x factorial, x minus 1 factorial, p raised to power x minus 1, q raised to power n minus x. So let n minus x be y and x minus 1 be k. So normal normal, if x minus 1 na k, x go be what? K plus 1. So NP na n minus x dey here. You don n minus x factorial y factorial over n minus, you know say na n minus x factorial dey here. We don turn am to n minus x, which is k plus 1 factorial x factorial, which is x minus 1 factorial wey dey here, which is k factorial. P raised power na x minus 1 dey here too. We don let x minus 1 be k. N minus x wey dey here, we don turn am to y. So after you do am like that, you go get y factorial over n minus k factorial, n minus k minus 1 factorial. That is, if you use one open bracket, you go get n minus k minus 1 factorial, k factorial, p raised power k, k raised power y. And np times summation y factorial over, I just rearrange am like this, n minus k, n minus 1, n minus 1 minus k factorial, p raised power k, k raised power y. So we don talk say make n minus 1 sorry, make n minus 1 be what? Be y. So e go be n minus 1 minus k factorial, k factorial. So n minus 1 wey dey here, e go turn y minus k factorial, k factorial, p raised power k, k raised power y. So where all this one, summation of everything wey dey here na wetin? Na 1, as per proving of a proper probability distribution. So if you sum all your probability or all your sample points in your sample space X, you have 1. So we have NP times 1, which is what? NP.